let's discuss quadratic equations. So the first thing we need to know is how the standard form of a quadratic equation looks. We have lowercase a, b, and c. This is very important that we can identify a, b, and c as our coefficients. The next thing I need you to notice is that there's a 2. So this would be a second degree. So what does this mean when there's a 2 above x, or x raised to the second power? Well, this means that x will be equal to some value and x will be equal to another value. So in the previous video we learned that x would have one value when it comes to a linear equation. But now with quadratics, if we see a 2, x will have 2 solutions. The same thing for when I see x raised to the third power. That would give me 3 solutions, and so forth. So how would this equation look? Well, it would look something like this, right? Where we have our function, so let's write the f of x is equal to ax squared plus bx, plus c. We will have 2 points crossing on my x-axis. Now, this is not always the case, but most of the times, especially for high school mathematics, this would be the case. So what we're actually doing when we factor these type of equations is we're finding these 2 solution points. Now, when it comes to quadratic equations and quadratic functions, a few fields where it's very important are like things like finance, physics, architecture, and also even computer graphics. So when you want to create animations and game development, you use a lot of these type of functions, right? So let's go solve some equations. Or if I can give you a little tip and trick, always look at this value first. Decide which 2 values can I multiply to create 4, right? There's a couple of methods that some teachers use. Some teachers use this, where they have 4 and then they input 3. Other teachers use these 2 boxes, and then we have A, C, and B. But what I like to do is I like to solve these equations mentally, so it saves up some time. So I'm going to say 4 multiply 1 gives me 4, right? Now I need to find negative 3 by adding. So I can add or subtract these values from each other. So if I say negative 4 plus 1, I get negative 3. So all I simply have to do now is write x minus 4, x plus 1. And then to solve x, I need to set this equation equal to 0. So what I will do first is I will say x minus 4 is equal to 0. Therefore, if I transfer from the left-hand side to the right-hand side, x is equal to 4. And x plus 1 is equal to 0. Therefore, if I again transfer from left to right, I get x is equal to negative 1. Let's look at the second one. Now the second one's a little bit tricky, because I first need to realize here that, well, now all of a sudden x has a coefficient. Can I do something with this coefficient? Well, I can factor a 2, because 2 is a multiple of 2. It's also a multiple of 24, which is also a multiple of 40. So I'm going to factor with a 2. I'm then left with x squared plus 12x plus 20. Now I'm going to try solve this. Well, we have a 12. Well, what times what can give me 20? Well, logically I can see 10 times 2 is 20, right? I need positive 12, so it's going to be 10 plus 2. So there I have my 2 parentheses. So I can then say, well, x plus 10, x plus 2. I'm going to set this equal to 0 and solve. So x plus 10, transfer from left to right, becomes x is equal to negative 10. And we're also going to do x plus 2. Well, x plus 2 is equal to 0. So if I transfer again from left to right, becomes negative 2. Now you might wonder, what happened to this 2 over here? Well, let's investigate what happened. Okay, I'm going to continue on this side. I need you to think about this. This is how the theory would look behind it. If I say x, 2 plus x, 10, x plus 2 is equal to 0. Well, I know that I want to solve this part. So what I'm going to do is I can determine this as x, y, z, right? This is just, again, for educational purposes, so I don't really want you to name them x, y, and z. People will think, hey, what is this guy doing? Well, I'm going to divide both sides by 2 to get rid of this 2. Now, anything divided by 0 is 0. So we have x plus 10, x plus 2 is equal to 0. And now let's say I have y and I have z. Now z is going to be my coefficient of y. So I'm going to divide both sides by x plus 2. And again, the same thing. Then I just get x plus 10 is equal to 0. And then I can transfer from left to right. So x is equal to negative 10. Now you can skip all of this. You can skip this entire process. But that's just the theory behind how it looks. I made a little bit of a mistake by graphing so closely. Anyway, let's do the next one. I'm going to rewrite this equation over here. I know I skipped C. It's just I'm a little bit cramped for space because of all of this information, but it's fine. Okay, first things first, I'm going to see, well, I have a coefficient, so I'm going to factor with this coefficient. I'm going to take out 1/2. What actually happens? Well, a common mistake would be to think, well, I'm going to take the half of 4. But no, my value actually increases to 8x. And I'll explain in a bit why that happened. And then we have plus 14. So as you can see, both of them are doubling. Right? Both of them are doubling. So why did that happen? Well, that happened because if I multiply 1/2 with 8, I get 8 over 2, which is then equal to 4. Now we have this weird equation. Let's see. So 7 times 2 is 14, but that does not give me 8. What about 14 and 1? That does not give me 8 either. So now I have to use a process that's known as the quadratic formula. So what's the quadratic formula? Well, the quadratic formula is negative b plus minus the square root of b squared minus 4ac over 2a. Now, remember earlier when I told you it's important to know the standard form of a quadratic equation? And this is exactly why. Because now we see that our a value, in this case, is equal to 1. Our b value is equal to 8. And our c value will be equal to 14. Now, interestingly enough, when you have two higher values, that's both positive symbols, you'll find complex numbers, meaning it'll be, we will have a negative square root, which will then give me an error on my calculator. Or we can even simplify that by using the term I, but that's a topic for another video. So let's see if we can solve this one. So I'm going to say negative 8 plus minus b squared. 8 squared is 64 minus 4 multiply 1 multiply 14 over 2. Oh, we can actually find values here. Never mind. We won't have a negative square root. Okay, so I'm going to type this in on a calculator. Fraction, negative 8 plus, I will do plus first, 64 square root of 64 minus 4 multiply 14 over 2. So my first answer is negative 2.58. So I'm going to say my first x is equal to negative 2.58. Let's go find x2. Now instead of clearing my entire calculator, I'm just simply going to go back and replace the positive with a negative. Then I get negative 5.41. So therefore my two intercepts are negative 2.5 and negative 5.41. Okay. Let's get to this final one. So I'm just going to rewrite C down here. Now we have the exact same situation where we see that, well, we can't figure out what times what gives me negative 21. That's clearly impossible since 3 is a prime number. But what we can use is our good friend, the quadratic equation. Negative b plus minus the square root of b squared minus 4ac over 2a. Just out of interest, this is actually known as the discriminant. Especially in IB mathematics, you have to deal a lot with discriminants for finding solutions. But again, we can do that another time too. So let's identify a squared plus bx plus c. Let's identify a is equal to 1, b is equal to negative 21, and c is equal to 3. So let's input our values. Let's calculate the x's. So negative 21 plus minus the square root of negative 21 squared minus 4a is 1, 3, or c is 3 over 2 multiply 1. I'm going to calculate my first x. I'm going to go back to my calculator. I'll say fraction 21 plus the square root of negative 21 squared minus 12 over 2. So my first answer is 20.85 ... And if I go back to my calculator to simply replace the positive with a negative, I find 0.14. And this is how we find x-intercepts, by using the quadratic equation, factorizing.